Hi, welcome to Unit 4, Day 6. This is Part 3 of ionic compounds and their chemical formulas. We'll be focusing on this part on transition metals. So just to recap, the aim of this lesson is for us to be able to check a chemical formula of an ionic compound and see if it's correct or not. And we've already looked at how to do that for very basic or simple ionic compounds like Al2F3. Then we looked at how to do that for more complicated, so the ternary ones that include polyatomics. Now we're going to look at how to do that for transition metals. So first of all, let's recap what transition metals are. It's mainly in this D block of the periodic table. The reason why this is important for us to do is because transition metals charges can vary. Other metals in addition to transition metals whose charge can vary, some things like lead and tin as well, just so you know. So even though these aren't transition metals, they're called outer transition metals, I guess, they also have varying charges. So you may have to figure those out as well. Now, things to know about transition metals. They do not have common ionic charges. And again, that means their charges can vary. For example, something like copper can have a +1 or a +2 charge. Iron can be +2 or +3 charge. And because their charges can vary, we actually have to figure out what their charges are from a chemical formula and the anion in that chemical formula. Now to do that, you can use sort of mental math, or you can follow these steps listed here. So the steps are to multiply the subscript and charge on the anion. So let's say you have an anion, chlorine, Cl, which is in group 17, so it has a -1 charge. Okay, here it is, chlorine. And you have 3 of them. You would do 3 chlorines times -1 and gives you an overall anionic charge of -3. The next step is to take the number you got, that -3 number, for example, and divide it by the transition metal subscript. So if the transition metal you're dealing with is copper, and the copper has a subscript of 1, then you would do -3 divided by 1. Then the last part is to flip the sign so it's positive. Remember, we're looking for the charge of a metal, and metals have positive charges, so the number that you got in step 2 would be a negative number, so we're going to flip it just to make it positive. So that means the copper would have a +3 charge. Now the reason why these steps work is because, remember, the overall charge of the transition metal and the anion must equal 0. Remember that for any ionic compound, when you add up all their charges together, it has to equal 0. And that's what these steps sort of allow us to do. So again, you can either use mental math, figure out what the charge must be in order for the overall charge to be 0, or you can follow these steps. All right, so here are some examples. Now, in this video, we're not going to go through each example step by step. So if you want to see more step-by-step stuff and done out by hand, you're going to pause this video and then go to video part 3 example. But in the meantime, let's take a look at these examples that we have here. So we want to know the charge of the transition metals. And here are the answers. So let's go through sort of how we would figure that out. First thing that you notice that I've done for all of these problems is I sort of highlighted what part was our metal and what part was non-metal. You always have to do that with this, and you'll see in a lot of these examples where you identify your metal and your non-metal part. Once we have that, the non-metal part will be our negative charge, our anion. So in this first example here, the non-metal is chlorine, Cl, so I find that in my periodic table. It's in group 17 and has a -1 charge. I have 2 chlorines, so each one will have a -1 charge, and since I have 2 of them, overall I would get a -2 charge from the anion. So the anionic charge will be -2. So to figure out the charge on the lead, the transition metal, what I'm asking myself is, well, what charge must be on lead in order for the overall charge to be 0? Meaning, if I have a -2 here, what must the charge of lead be in order for, when I add them together, it will be 0? And the answer to that would be +2. All right, we can do the same thing for the next example. So for silver, the non-metal is oxygen, so I'm going to focus on that first, figure out a charge of oxygen. It's -2. All right, we've got a -2 charge there. Now on the cationic side, where the metal is, I have 2 silvers. Now, what must the charge of the silver be in order for the overall charge to be 0 if the oxygen is giving me a -2 charge? Well, okay. So that means that the silver, each silver must have a +1 charge in order for the overall charge to be 0. If we look at an example for copper oxide, we see that oxygen again has a -2 charge, and I have 3 of them. That means that overall the oxygens will give me a -6. So the subscript 3 times its charge will give me a -6. Okay, well then what must the charge of each copper be in order for the overall charge to be 0? Notice I have 2 coppers. So in order for the charge to be 0, this must overall give me a +6 charge. And since I have 2 of them, each one must contribute a +3. In example D, I have copper sulfate. Sulfate is a polyatomic ion, so unless I've memorized the charge, I have to go to this chart and find it. Sulfate is here, it has a -2 charge. So the question is, I have 1 sulfate and 1 copper. What must the charge of copper be in order for the overall charge to be 0 if sulfate has a -2 charge? Well, that must be +2, because +2 and -2 will give me 0, so copper is +2. And the last example here, with iron nitrate, we do the same thing. We look at iron, we look at, we look at the anion nitrate, NO3, find it in the table, since it's a polyatomic, it has a -1 charge. Each one has a -1 charge, and since I have 2 of them, that means overall I have a -2 charge from this side of the formula. So if I have an overall -2 charge, well, what must the charge of iron be in order for it to be, the overall charge to be 0? And so that has to be +2, because +2 and -2 will give me 0. So if you want to see these examples done out, you can pause the video and then do the part 3 examples video in this folder. Okay, so here you have your CFU example. What is the charge of the transition metal? And you're going to do that for each of the CFUs. So pause the video now. When you press play again, the answer will be revealed. All right, take a look. Here are your answers. Okay, so now that we've gone over these, you look at these answers, let's summarize some key ideas from this lesson. First of all, first key idea is that the chemical formula of an ionic compound is correct when. Remember, we're trying to figure out when it's correct. Well, when is it correct? First off, when the sum of ionic charges equals 0. So when you add up all of the charges, they have to equal 0. Secondly, the chemical formula is what's called the empirical formula, meaning that the subscripts are the smallest whole number ratios possible. So in an example of aluminum bromide, it's AlBr3, not Al2Br6, because Al2Br6, those subscripts, 2 and 6, can be divided by 2, so those aren't the smallest numbers possible. Next up, determining ionic charges. How do we determine these ionic charges? Well, if you're dealing with main groups, that'll be group 1 and 2 and 13 through 18, use the common ionic charges in the periodic table. So for example, group 1 has a +1 charge, group 2 has a +2 charge. On the other hand, for polyatomics, you're going to use the charges found in that reference table that we've been using. So for the polyatomics, you have to look those up. Transition metals, on the other hand, you actually have to calculate the charge from the charges on the anion using the steps or mental math. So remember, transition metals have varying charges, so you have to figure those out. Next key idea is that when calculating the sum of formal charges, remember you have to multiply the subscript and the ionic charges of each element. So if the element has a subscript, don't forget to multiply that with its ionic charge. And just to recap, subscripts are the small number in a chemical formula that tells you how many atoms or polyatomics are in a molecule. If you're dealing with polyatomics, don't forget that the subscript that you're using in this case that tells you how many polyatomics you have are the subscripts on the outside of the parentheses. Now, for anyone who's wanting to do a little bit more, learn a little bit more about ionic compounds, there's an extension activity on how to draw Lewis dot structures of ionic compounds. So you can do that extension activity, which is in this folder. And don't forget, before you close this folder out, to make sure you do the graded practice and complete your KWL and submit it. All right, that's it for this video. These are the resources that you'll be using throughout, and this is also posted in there. I hope you found this helpful. Have a quality day.